Hello again, this is UML Operator. Okay, this is part 3 of a multi-part series on understanding associations in UML. So far, we have touched on instance-level relationships and class-level relationships. However, dependency is a weaker form of relationship, which indicates that one class depends on another before it uses it at some point in time. So I've created a working set called Dependency Session. I'm going to go ahead and launch this. Y'all should have learned about working sets in a previous video. I'll try to include the link in this session. Let's go to pan and zoom, and let's make this fit to the screen. There we go. So as we move from our UML association conversation to dependencies, we need to understand the different types of elements that we use, because each one of them may react differently, respond differently, even tell different stories in our modeling exercises. Here we're using a component diagram toolbox where you see components, classes, packages, or what I've referred to as namespaces. In the Unified Modeling Language, or UML, a component diagram is a type of structural diagram that illustrates the high-level structure of a software system or application. It focuses on the organization and dependencies of the components that make up the system. As we spoke of in part 1, a class is a blueprint or a template for creating objects. An object represents a runtime entity that belongs to a specific class. However, the term object and object instance are important to understand, especially in modeling and using dependency references, and often used interchangeably to refer to a specific occurrence or occurrence in memory of a class. Therefore, an object represents a runtime entity that belongs to a specific class, while an object instance is a concrete occurrence of an object in memory, referring to a specific occurrence or instantiation of a class. So with this in mind, let's look at some different uses. First, let's add some thinking when drawing or modeling dependencies. When we draw or model lines, we have a source and we have a target. This is very similar to any other association. Component A is the source, and the interface to component B is the target with an open arrowhead. As we model each line, dependency in this case, the source side is the depends on side, and the arrowhead side is the needed by side. I want to move my properties window. I'm going to move it up here, and I want to be on traceability, which I landed on. So with traceability turned on, when we select component A, we see that component A depends on the interface. When we select the interface, this lollipop of component B, we see that the interface is owned by component B and needed by component A. Let's switch from component elements to class elements. In this particular case, we see that we have a source and a target. And I just named these classes that to help clearly understand the source and the target. The dependency that we drew came from the source to the target. These could be named anything, all right? So when we look at the source, we look at traceability, we see that source depends on target. It's on the starting side of the dependency association, an arrow. When we look at target, we see that target is needed by source. So needed by is on the arrow side if an arrow exists. You'll notice when you're drawing a dependency that you have the ability here in properties to set the direction. Unspecified bidirectional, which you probably shouldn't do in dependencies, source to destination, and destination to source. So I could change this destination to source if I had a different meaning. I'm going to take it back to source to destination. In some cases, just like down here, you have the source as the client and the supplier as the target in this package reference, but you have no arrowhead. And this can be confusing to folks unless you add more intelligence under the line. In this case, we named the line, didn't use a stereotype, and we used a directional icon reference to show that the direction is actually going destination to source, right? So very important to understand when you're using this. I'm going back to unspecified, no arrowheads, and we're going to go back up here. When you're drawing arrows, that you probably should use an arrowhead. I recommend not doing this, and we'll talk about this in a moment. So you'll notice that we have a stereotype called instantiate here. And simply what this means is that the object or class instance instantiates, telling the story in this model that the source class is instantiating or invoking something in the target class. In this diagram, we have two classes, class 1 and class 2. Well, let's draw a dependency from the source to the target, class 2. So we're going to go down here, we let go of the mouse button, and we're going to go to dependency, and we're going to draw a dependency. You could also use the toolbox, find a dependency association, and draw the line that way, because there's common relationships. You can go down in the toolbox and you can find dependency down here and do the same thing. But it's faster to use this up arrow off where you're drawing the line from, the source, to the target. Now let's add the stereotype instantiate to this line, this dependency. And there's a couple of ways of doing this. Number one, you could go over to properties and you'll find stereotype. You can click the triple dots and it gives you a selection, all right? And I'll get more into stereotypes a little bit later on, but we're going to look for instantiate. And here it is right here. We can check this box, hit OK, and there we've added the stereotype instantiate. The other way, if you don't have property window up, is simply double click on the association, in this case dependency, and then you can go to stereotypes, hit the triple dots here, and find the stereotype that you want to use in a particular association, in this case dependency. You can also turn off a stereotype or stereotypes by simply checking it off, hitting OK, and now it is removed. Let's go ahead and bring it back. We're going to do it over here in stereotypes, again in property windows. We're going to come here, we're going to look for instantiate, and we're going to select that. While we're here, I also want to state you can add multiple stereotypes to a single line. In this case, import and instantiate were used in this dependency. Now, be careful in doing this because you're using two stereotypes. Of course, you're using it to extend the meaning of this association, in this case dependency, between these elements. I would probably do two different dependencies. We'll talk about that in a moment. But for now, I'm going to double click on this. I'm going to go to stereotype. You can see I have two stereotypes. I'm going to select this and I'm going to click off import and leave instantiate. Hit OK. And there we go. We're back to just instantiate as the stereotype for this dependency. So stereotypes are one of three types of extensibility mechanisms in UML, Unified Modeling Language. And the other two are tags or tag values and constraints, which we'll cover in later sessions, not in this session. Stereotypes allow the designer or modelers to extend the vocabulary of UML in order to create new model elements, or derive from existing ones. We got into templates and things like that, but that have specific properties that are suitable for a particular problem domain or otherwise specialized usage. Graphically, a stereotype is rendered as a name enclosed by guillemets, all right? And placed above the name, if you were using a stereotype in an element, often in the associations, it's below the line or dependency in this case. So in this case, what we're stating is we have two classes and a instantiate dependency between them. So we're saying it, we're telling the story, or we're saying that the operations of the source class creates or instantiates an instance or instances of the target class. So in this example, class 1 depends on class 2 through an instantiate dependency. Class 1 creates instance or instances of class 2 as part of its own functionality. The dependency indicates that class 1 requires or depends on class 2 to exist and function properly, and thus class 2 is needed by class 1. It's important to note that the instantiate dependency is a specific type of dependency, and it differs from other types of relationships in UML, such as association, aggregation, and some of the other lines or associations that we talked about in the previous sessions. It specifically emphasizes the act of creating objects and the direct dependency between the classes or elements involved in the instantiation. Let's look at the UML types that Sparx helps you define and manage. So we're going to go to the Settings tab. In the Reference Data panel or group, we're going to go to UML types. We get a dialog box that pops up that has stereotypes, tag values, and cardinality. All right, constraints are managed elsewhere, but we're just going to be focused on stereotypes. Applies to, let's go ahead and sort this, and let's go down to dependencies, since that's what we're referencing. And here, let's just click on instantiate for a moment, and let's look at what Sparx defines this stereotype and the base class it applies to as. You can see that Sparx defines instantiate as operations on the source class creates instances of the target class. So it's very important when you're defining associations that you put as much notes or understanding, be as concise as possible, don't type War and Peace in here, of what the stereotype is, what the base class is, and then if you are grouping your stereotypes, which you have the ability to do for other naming conventions and approaches and profiling and all of that, we'll talk about in another session. It's very important to be as clear as possible when you're defining your stereotypes. When we look at these other stereotypes like invokes, look at the notes, migrate, and new, there's very little notes or intelligence under these stereotypes. Therefore, we're making assumptions that we know what invokes means. We know that what migrate means, and we know what new means. I think this is not a good practice. I believe that when you're creating a stereotype, you should define what the stereotype is, especially what it applies to, in this case, dependency, and be as precise, concise as you can. It just helps you in the future when you're going back on stereotypes, and that you understand what that extensibility, what that extension means. Let's go back to our dependency diagram and let's focus on package dependencies. So we have three dependencies here: import, right here, supply, and then no stereotype, we're using name and a direction indicator. Now that we understand depends on and needed by, we can read these dependencies without stereotypes only if we understand the roles of the client and the supplier, the source and the target. In this case, we've named the packages, these namespaces, client and supplier. However, if we're just looking at pictures and no intelligence about what is under these pictures, these elements, this makes it difficult to understand the elements, more importantly, their roles. In addition, if we don't understand what the arrowheads mean and use ambiguous stereotypes, this can too cause confusion and problems. Can a client import something to a supplier? The answer is yes. But can a supplier import something to a client? The answer too is yes. However, if we understand the stereotype import and what it means, such as public contents of target are imported into source namespace, and we understand that the client depends on the supplier, and that the client is the source and the supplier is the target, now the meaning of this content or contents from the client are imported into the source namespace or package make more sense. Thus, the client is providing something to the supplier, the client depends on the supplier, and the supplier is needed by the client to process this objective, this extension. In the next dependency, we see supply as the stereotype. This is not a standard form in UML per se, but was introduced over 20 years ago by Erickson and Pinker and is used in Sparx and other tools dealing with business process modeling, notation, BPL, and so on. Thus, what we're saying in this graphic or this model is that the supplier is dependent on the client, and the client is needed by the supplier to participate in some process. I would say that this form of dependency is a weaker form of import stereotype, and I would exclude from the model. Now let's look at the dash dependency line with no arrowheads. There is a source and a target here, but it's hard to tell for the readers looking at this model. A name is provided, import, and a direction indicator is included. But is this enough to tell a story of what you're doing in traceability between in this case, source, or this source, and this target? Are you able to tell using this dependency? So the dependency, when we select it, clearly states in properties that client is the source and that supplier is the target, right? But this is probably not a good practice. You may want to do it in some cases, but it should be limited. We really should only use, in this use case, this type of import dependency and stereotype, and then put some intelligence underneath your lines, more than this, if you will, to let the readers know when you're doing reporting, you're telling the story of what this namespace or package is doing compared to this namespace or package. Here we have three different types of modeling elements. We have an actor, we have two objects, and we have a collaboration. It doesn't matter which order we start with or model them, but let's tell a story. The story we want to tell is the actor depends on object one in order to do something, and object one depends on object two to provide something. And object two depends on collaboration, which is the cooperation and communication between participants. All right, so let's draw or model this diagram. Now we're going to use dependencies. You can use any line association you want to tell your story, but we're going to use dependencies. These are objects, not classes. Actor object, collaboration, so on, right? So what we're going to do is we're going to draw a dependency, hold down this arrow, drag it up here and let go, and we're going to draw a dependency, right? So what we're stating here is that, and let's go to traceability, actor one depends on object one. So let's add some clarity. And what we're going to do is we're going to go to roles and we're going to say actor one depends on, and we're going to say that the target is needed by, all right? We're not going to add any multiplicity in this case. So we're stating is actor one depends on object one, and that object one is needed by on the arrow side, all right? And let's continue to do this. So we're going to draw a dependency between object one and object two. So again, we're going to use dependency. We're going to double click in here. We're going to go to roles, and we're going to say on this side, it depends on, all right? And on the object two is needed by, all right? So we'll draw that in. And let's do this again. Drag and drop this to collaboration from object two. We're going to use dependency, right? And that we're going to open this up, go to roles, and we're going to say object two depends on collaboration 1 needed by, right? So we've learned a lot about the dependency association. We could certainly apply stereotypes in this case, but this is how you would model dependencies, and this helps your readers understand what's going on. Now, what you would be doing, of course, is putting a plethora of notes and information and intelligence under the associations, under the elements. So when you're doing reporting, you have a much clearer picture of what's going on in this story. Now, what's interesting when you're applying the system architecture and you're using distributive mathematics, data science, etc., that if the actor is trying to get to a particular object or class or element to do something, and it's needed, this something is needed by this actor, then this object depends on or needed by object 2. You start to be able to create a pattern here where you're painting in, well, this could be an API object, this could be some sort of class element with operations and attributes that is used to build this object necessary to get into collaboration or whatever this object is. So if that's the case, isn't the ultimate dependency that the actor is trying to get to a particular collaboration, something? It depends on, all right, depends on, and therefore this is needed by. So when we go to roles on the collaboration side, needed by collaboration. Well, collaboration is needed by object 2 in order to trigger something for the actor starting in object 1. But if we select collaboration, look at this, collaboration is needed by the actor. So you're able to drill down with traceability, and you'll have more intelligence underneath these particular elements and associations to help reporting and then eventually driving code, applying these principles of understanding, right? So this is a true statement. However, the actor is just not going to whatever this collaboration or collaboration use instance is. It has to go through these objects, these method invocations, whatever the dependency is, in order to achieve this goal or objective. Therefore, you may be able to come in here in this stereotype and find something that means goal. There's actually a goal stereotype. It's not, I don't see it available here, but you could use stereotype, reuse stereotype, some other stereotypes to better understand. I'm going to cancel because I don't want to do that, what this dependency is between here and here. But this is just giving you a rough understanding of how we would use objects versus classes and other elements like package or component in order to depict behavior. So let's wrap up. We've learned that dependency is a weaker form of relationship, which indicates that one class or object depends on another because it uses it at some point in time. It's important to note that dependency association is a rather generic relationship and does not imply a strong or specific dependency like the associations defined by other UML relationship types we talked about in the previous sessions, such as associations, aggregation, or compositions. Instead, it indicates a more loosely coupled and dynamic dependency between elements. So I hope that this session has helped you better understand dependency associations, and that this series has helped you understand UML associations when you're modeling and drawing in any UML platform. While we're just touching the surface of the power of model-driven anything, you should have enough to advance your modeling capabilities and produce more meaningful visuals, models, diagrams that can be used in any of your collaboration material through modeling, telling your stories. Thank you for watching and spending some time with me. Please leave comments below, good or bad, and let's work together as we progress together. Thanks again. Happy modeling, and I'll talk to y'all later.